Hi, today we're going to deal with the really exciting stuff. We're starting to deal with shapes, right? Let's understand how shapes hang together. As engineers, we really enjoy this part of mathematics because this is what makes life interesting for us, because we build things. Okay, right. So if we look at 1 and 2 dimensional geometry or shapes, right? Geometry is just another word for shapes, the relationship between shapes. We're going to deal with points. Point is a single object and a single dimension, so it's called one dimension. A line is an ordered collection of 2 points. You'll see some more about that now, but it's still a single dimension. 2 lines are a collection of lines, 2 of them, that may or may not intersect. We're going to do intersecting lines just to explain something further. All right. Shapes and properties of multiple lines. When you put lines together, you get shapes. Right. So let's look at points. A point is a place that is very small. It certainly is one-dimensional. A point should be infinitesimally small, but we do need to actually see it. So if that's a point, right, it's actually in there somewhere. But we can't work with that. We need to actually see it as a point. Right, let's carry on. Now that we've dealt with points, let's look at a line, right? And let's look at a straight line. We don't want to deal with curved lines at the moment. We're going to get there. Right, so a line is simply the shortest distance between 2 points. So if we have point 1, remember this should be infinitesimally small. I'm just infinitesimally small. I'm just indicating that point for you, like the sights of a gun. We all play games, we will look at that. All right, and the line is simply the shortest distance between those 2 points. Okay, so let's have a look at 2 straight intersecting lines and what that all means. All right. So if we have these 2 lines and they intersect, intersection simply means that they are crossing over each other over there. We're just using this to explain some other concepts. All right, we find some interesting things happen. The relationship between the 2 lines certainly implies that we have got 2 dimensions. So we're in a 2-dimensional shape. The moment 2 lines cross each other, we're in 2 dimensions. And now there are all kinds of interesting things that happen over there. Right? So firstly, right, we have angles between the various portions of the lines that intersect. That is an angle. This is an angle. Right? And all of these angles are like that. Now it's very interesting to note, right, and you sort of can feel it and you can sort of see it, that angle is the same as this angle and that angle is the same as this angle. So those are just properties. Okay. The moment you have a 2-dimensional shape, you have all kinds of interesting properties, and the properties here are angles. Now all shapes that we can think of are simply a combination of lines. Even circles, and I'll prove that to you in this video. We'll show you how a circle makes up a line. Let's join some lines together. Right. We have a triangle, 3 lines. I happen to have drawn them kind of the same length over here, and that means we've got 3 angles, 1, 2, 3. There are also 3 outside angles, but we're not going to even talk about outside angles anymore. We're just going to talk about the inside angles for a while. But every time there's an inside angle, there's also an outside angle. Let's just remember that. There we've got 4, right? That's a trapezium. Okay, we've got 4 lines and 4 angles. So we're starting to build up a little bit of a picture over here. The angles are very interesting, right? And we've got 4 lines there and 4 angles inside. What's becoming interesting to note, again, is that the number of lines that make up a shape equal the number of inside angles or outside angles. 5, pentagon, same thing. And even a shape like that, it holds true. There's 6 sides to that if you count them. 1, 2, 3, 4, 5, 6. And so we'll have 6 lines and we'll have 6 angles inside. I'll leave this up a little while so that you can look at it and count it yourself. And that's absolutely true. Wow. This means something to us. The number of lines and the number of angles are always the same. And that's very, very interesting. So let's look at this in a little bit more detail. How do we get to a circle? Right, so let's just say lines must be equal in length when we draw up shapes. Then we can see triangle, 3 shapes, 3 lines, 3 angles. If the lines are all the same, the angles will all be the same. Remember, we're saying equal in length. 4 lines, 4 angles, and the inside angles are becoming bigger. Can you see that that angle there is smaller than this angle here? The angles are all the same inside because the lines are all equal in length. But the angles, the shapes become bigger and bigger. So if we've got 5 angles, and that angle is now bigger than that angle. Right? And you can see that. Draw it for yourself if you're unsure. You can certainly see it. And so we carry on. We keep adding sides, right, which are lines equal in length, and they produce angles, and the angles become even bigger and bigger and bigger. So that angle is bigger than this angle, is bigger than that angle, is bigger than that angle, and so forth. So even when we've got 12, like on the bottom over here, they're big, and they get bigger and bigger and bigger. Right. This is the relationship. More sides mean shorter lines for the same area. All right, so shapes that are more or less the same size, the more sides you've got, the shorter the lines will become. The lines are all the same size, so shorter lines means larger inside angles. But they never quite become straight, because if they become straight, we'll be back to a line. Think about it. If you make the angles absolutely straight, so that there's no angle, we're back to a line. Right. So what about a circle? A circle is just simply an infinite. That just means a hell of a lot. Many similarly sized lines joined together, right, make up a circle. And the angles are never quite straight. Okay, they're very close to straight, but never quite straight. So, guys, math is great. Math is really great. I want you to think positive. We're going to start doing a lot more interesting things. Like this video, share it, subscribe, do whatever you think is good. I'm going to start producing a lot more of these videos now because I've had very positive response. But above all, go to mathforyou.today. That's our website, right? And we're a bunch of teachers over there that are coming together to produce Common Core mathematics for the world. Thank you all.